Ladies and gentlemen, I'm very glad here today to introduce the course of Database Development Specifications. Database development is a process to design a database, and a good database design not only meets software requirements, but also meets requirements such as easy maintenance and expansion. Database design includes DB design, table design, field design, primary and foreign key design, index and constraint design, and so on. And in this lesson, we will learn some suggestions in the design of GaussDB. Upon completion of this course, you will be able to understand the database design and recommended database object naming conventions, best practices for database table design, best practices for writing SQL, and also we will introduce some contents about the stored procedure development. Before we start, let's make sure we agree on some terms. Specifications here is specifications on database programming and design. If you do not follow the specifications, the database will report errors. A rule is a convention that must be followed during programming and design. A proposal is a convention that is recommended to be considered. A notice is a convention that you need to notice during programming and design. And note is an explanation for a rule or a recommendation. And finally, example is either a positive or a negative example of the rule or recommendation. And now let's begin. In this course, we will introduce 4 chapters. And the first chapter here is the database design and recommended database object naming conventions. Insufficient readability of database objects can lead to low data utilization efficiency, which in turn affects development process. So we'd better comply with database object naming conventions from the beginning in order to avoid certain problems. The naming of database objects need to comply with the following rules. First of all, a database object name should contain a maximum of 63 characters, starts with a letter or underscore, and can contain letters, digits, underscores, and $signs. And secondly, please do not use reserved or non-reserved keywords to name database objects. We can use this SQL statement to query all the keywords in GaussDB. And besides that, we have 2 proposals here. Firstly, it is suggested to avoid using double quotation marks to define names of database object. This is because our GaussDB database is case insensitive. Object names without double quotes are assumed to be lowercase by default. So after we add double quotes to the object names, they become case sensitive, which will increase the difficulty of debugging. You can see from the following example that a table named stuff was created, but could you tell at a glance which table this insert statement is trying to operate? We can see that this is really confusing, so it's not suggested to use double quotation marks to name database objects. And also, it is suggested to use the same naming format for database objects. So in a system undergoing incremental development or service migration, you are advised to comply with its historical naming conventions. And now, after a short introduction of database naming conventions, let's discuss the best practices to design database objects. So first of all, in GaussDB, you are advised to use schemas to isolate services for convenience and efficient resource sharing. Actually, in GaussDB, you can either use database or schema to achieve business isolation. The difference is that database isolation is more thorough. Resources are rarely shared between different databases. It can achieve connection isolation, permission isolation, and so on. There is no direct mutual access between databases. But compared with DB isolation, schema isolation methods shares more resources, and different users can easily control the permissions of each schema and its subordinate objects through the grant and revoke syntax. Also, for better database management, it is recommended that system administrators create schemas and databases, and then assign required permissions to users. For the design of database and schema, here are some suggestions. The first rule is to create new databases according to requirements, rather than using the default database of the cluster. This is mainly for the convenience of management, because in this way we can intuitively find the corresponding business through the database name. The second one is when creating database, it is important to focus on two configuration items, which is the encoding and compatibility. GaussDB supports 4 compatibility modes, which is A, B, C, and PG, indicating that GaussDB is compatible with the Oracle, MySQL, Teradata, and Postgres syntaxes. The syntax depends on the compatibility mode. And here, the default compatibility mode is Oracle for a centralized cluster and MySQL for a distributed cluster. And next one is a proposal. To store and represent most characters, you are advised to use the UTF-8 encoding when creating a database. Also, it should be noticed that by default, only the owner and the system administrator have the permissions to access schema objects. So to allow access to a schema object, you need to assign the permissions to the schema and the corresponding permissions to the objects. And now let's see some suggestions for database table constraints. First of all, if all the column values can be obtained from services, do not use the default constraint, or unexpected results will be generated. For example, if you specify an integer column to have the default value of 0, then it may be misleading when you need to calculate the average value for that column. The second one is add not null constraint to columns that never have null values. In this way, the optimizer will automatically optimize the column in certain scenarios, which could help us to improve the performance of the database. And thirdly, explicitly name all constraints, excluding not null and default. So here is an example. A constraint that tests whether a value is less than 100 can be named like less than 100. So we can tell at a glance at the constraint name that this constraint is used to constrain a column and make sure it is less than 100. This is pretty clear. And for constraints, we mainly focus on these 3 different types: unique constraints, primary key constraints, and check constraints. Unique key constraints can be used to ensure that all values in a column are unique. For example, the ID card numbers or mobile phone numbers of employees must be unique, and we can name it as like the UNI and with a column name. And for primary key constraints, it can be used to uniquely identify each row of data in a table. For example, in an employee information table, the employee ID is usually used as the primary key. And for this constraint, we can name it like PK and with a column name. And finally, for check constraints, it can be used to define more service rules. For example, the gender of an employee can either be male or female. So for those kind of constraints, we can name it as CK and with the corresponding column name. And finally, for this chapter, let's discuss some suggestions for views and join table design. First of all, for view design, please do not use nested views unless they have strong dependencies on each other, because this will reduce performance. And secondly, try to avoid sorting operations in a view definition. We can just perform sorting operations when we are actually obtaining data from the view. It is not needed to put sorting operations in a view definition, because this will also reduce the performance. Secondly, for the joined table design, here are 3 proposals. The first one is minimize joined table columns across tables. This is for like when we are trying to join 2 tables. We need to make sure that we minimize the joined columns. The second proposal is use the same data type for joint columns. And this is to avoid the implicit data type conversion. Thirdly, the names of joint columns should indicate their relationships. For example, they can use the same name. This is to clearly reflect the association relationship between tables. And now it's the end of chapter 1. And here we will take a little quiz in the class. Here we have 3 questions. The first question is, for GaussDB, are object names case sensitive? So as we mentioned before, the object names in GaussDB are case insensitive. So the answer is no. Secondly, can the character set be changed after the database is created? And the answer is no. We can't change the character set after the DB is created. And thirdly, which of the following is recommended for accessing objects? For example, tables and functions. And as we mentioned before, we recommend to use schema instead of database to achieve business isolation. So the best way to access the object is to use the schema name dot table name. So here the answer is B. And for the next chapter, we will discuss the best practices for table design. First of all, let's see the best practices for the design of distributed tables. For a distributed table, we need to specify its distribution policy. In GaussDB, we have 4 different kinds of distribution policy, including replication, range, list, and hash. In replication policy, full data in a table is stored on each DN in the cluster. It is suitable for the scenario where a table has a small amount of data and frequently joins other tables. And also, it is suitable for the scenario where the join query performance needs to be improved. And secondly, for the range policy, all records having a distribution key value in a specific range are assigned to the corresponding DN. So this is suitable for scenarios where users need to customize distribution rules based on the range, for example, a time range. And thirdly, for the list policy, records are mapped based on the values in a specific column and distributed to the corresponding DN. For example, there may be a column named type in a table, and this type column has only several possible values. And then we can create a distributed table with list policy based on this type column. And finally, in hash policy, records are distributed to DNs based on the hash of their distribution keys. And this is generally suitable for scenarios where a large amount of data needs to be evenly distributed. And since hash policy is most frequently used when defining distributed tables, let's see some suggestions on the selection of distribution key. So first of all, use the distribution key with discrete values so that data can be evenly distributed across DNs. For example, in the business scenario of banking, the business entity is the customer, and the customer ID field can be used as the distribution key for the business data because ID is unique and records can be evenly distributed based on the hash value of it. And secondly, select a join condition as the distribution key. So in this way, we can directly determine which DN the data is in during the query, improving the query performance. So in this introduction for the distribution key, we have a note here that for a hash table, an inappropriate distribution key may cause data screw and poor I/O performance on certain DNs. So for this reason, you need to check the table to ensure that data is evenly distributed on each DN. And we can simply execute this SQL statement to check whether the data is screwed. So here, if you get a result that is larger than 5%, then it can be considered as a data screw. And if the result is more than 10%, we need to choose another distribution key. And for regular tables, so before that, we are introducing the distributed tables. And now, for regular tables, there are also some design suggestions. The first one is use a data type that boosts execution efficiency. So generally, the calculation of integers is more efficient than that of strings and floating-point numbers. So when we are choosing the data type of a column, if we can choose integers, then it is more appropriate than strings and floating-point numbers. And secondly, use a data type with a short length. Using a data type with a short length reduces both the data file size and the memory used for computing, improving both the I/O and the computing performance. For example, use small int instead of int, and use int instead of big ints. And thirdly, use the same data type for joint columns. So if we do not use the same data type for joint columns, the database must convert them to the same type, and this will result in performance overheads. And now it's the end of chapter 2. So here we also have 3 questions in this small quiz. The first question is, what data type is best for phone numbers? So as we know that in different countries, we may have a phone number of different lengths, and also some phone numbers may contain like the hyphen marks. So the best way to define phone numbers is to use the variable char. So the best way is to use the varchar type. And secondly, what data type is best for age in an employee information table? And the answer is tinyInt here. So for the tinyInt type, we can have the maximum value of 255. And as we all know that a person's age, it actually is impossible to exceed 255. So tinyInt is just sufficient for the storage. And this data type is relatively small, which is good because it will help us to save some storage space. And thirdly, which distribution mode is best for an employee position table with hundreds of rows? So here we need to notice that this table is relatively small. It only has 100 of rows. So the best policy for this distributed table is the replication policy. And the following chapter, the third chapter, we will discuss the best practices for SQL queries. The where keyword is important in SQL queries, providing conditional judgment that allows us to filter out unnecessary data. And for where clause, the following are some design suggestions. Firstly, for the query on a distributed table, we should better include all distribution keys in the where clause. Otherwise, the queries will be performed on all DNs, resulting in some unnecessary resource overhead. And secondly, do not use scalar subquery statements. A scalar subquery appears in the output list of a select statements. So in the following example here, this is a scalar subquery. It appears in the output list of the alter select statements. And scalar subqueries often result in sharp deterioration in query performance. So we'd better revise that SQL. And to revise that, we can revise it in this way. We put the salesman table, put that to join with the staff table, and we can simply get the result we want through the join tables. And this will have the same result as the upper example. So now let's see the query plans for these two SQLs. In the left-hand side, this query plan is for the suggested revision. And for the right side, the query plan is for the negative example. And we can see that the cost for this revision of SQL statements is quite low, whereas the other one has a relatively high cost. So in order to improve the performance, we should avoid using this way to write a SQL statement. And there's another proposal that in the where clause, the filtering conditions should be sorted. So we'd better put these conditions with higher selectivity near the beginning. So this means that in this way, it will help us to filter some unnecessary data at an early age. So this will also help us to improve the performance. And next, there are also some other rules for the where clause. The rule is that do not include implicit data type conversion in where clause. An implicit conversion in a database may prevent the index scan from using and result in some performance issues. So here are some of the performance issues being listed. So in the right red words here are the two scenarios that is not good. The first one is, so the red words here are some bad consequences when we are using the implicit data conversion. The first one is DNs cannot be pruned. So if we use the implicit data conversion, the query plan of the SQL statement is delivered to all DNs for execution. And second scenario is index scan cannot be used to scan data in the plan. So in this case, since we cannot use index scan anymore, the query will be much slower than before. And after that, we can see an example here. So on the left side, we specify the phone number to compare with a big integer. So in this way, there will be implicit data conversion here. But on the left side, this is the right version to write the SQL. They will not have the implicit data conversion. And we can see that the cost of the left query is higher than that of the right query. Okay. And next, do not use expressions or functions in a where clause. Here, using expressions or functions in conditions will make the index scan invalid. So this will cause some unnecessary performance loss. So this is not suggested. And here we have an example. So here we have an expression of income multiplied by 12 in the where clause. And to revise that, we can move 12 to the other side of the mark. And in this way, we will not have expression in the where clause and the performance will be improved. And after the introduction about the best practices for where clause, we can now see some suggestions for the select queries. There are two proposals and one notice here. Firstly, when querying, we should try not to use wildcards in a select statement. Because when we are using wildcards, we're simply selecting all the columns of the table, but maybe not all columns is needed. So we should just specify specifically what columns we need in the select statements. And also, this may cause some front-end service compatibility issues. So for example, in two different versions, we have different number of columns in the table. But if we use the wildcards in the select statements for the front end to query, it will cause some compatibility issues. And secondly, do not frequently use counts to obtain the number of rows in a large table. This will consume a lot of resources and affect the execution efficiency of parallel jobs. So if we do not need the real-time row statistics, we can just run the following statement to get the real tuples from the PG class and specify the table name. And in this way, we can get the rough estimate of the number of rows of a specific table. And thirdly, do not perform operations that may cause sorting, such as order by, distinct, group by, and union on large columns. And this will also consume a lot of CPU and memory resources, resulting in low execution efficiency. And next is some best practices for the update clause. First of all, do not use the updated column as the update source. when the update clause updates multiple columns simultaneously. Here is an example of that. In this example, the department column is being updated, and its new value is the production department. And also, it is an updated column here, but it also serves as the update source for another column. So when we are writing SQL in this way, we will get different results in a database of different compatibility modes. For example, in NewSQL, the value of all statements is the original value of the department field. But in MySQL, the value of all department is the project department, which is a new value of the department field. And next, to avoid unnecessary sorting, do not use group by or order by clause in the update statements. And next, for deletes, also this is same as updates. To avoid unnecessary sorting, we should not use order by or group by clause in the delete statement. And also, secondly, use truncate instead of delete to clear a table. So here, truncate creates a new physical file and physically deletes the original file when the transaction ends to clear the disk space. But for the delete statement, it only marks the data in the table as dead. They do not clear the disk space until the vacuum full phase. So here is an example of writing truncate and delete statements. But they have a small difference here. So when we are truncating a table, we simply clear all the rows of it. But when we specify the delete statement, we can choose to delete a subset of the table when we are specifying the where clause here. And now that's the end of chapter 2. And at this point, we would also like to take a little quiz. In this quiz, we have 2 questions here. The first one is, what are the differences between truncate, delete, and drop? The answer is that for truncate table, it deletes all data and frees up spaces, but it does not delete the table objects. But for delete table statements, it deletes data, but does not free up space or delete table objects. If we really want to delete the table objects, we can use the drop table statements. The second question is that you can use count to obtain the number of rows in a large table. If you do not need the real-time row statistics, you can also run the following statement to obtain the number of rows in the table. We select the real tuples column from PG class and specify the specific table name here. But when will the number of rows be updated? So there are basically 2 scenarios where the real tuples column is updated. The first is when the service submits an analyze statement. So for example, we just execute vacuum analyze stuff. It means we analyze the table named stuff. And at this point, the real tuples of the table will be updated. And the other scenario is the auto vacuum process. So during auto vacuum, the real tuples column will also be updated automatically. The interval of auto vacuum process can be specified by the GaussDB parameter of auto vacuum nap time. And the triggering threshold of auto vacuum can be specified by auto vacuum threshold. And finally, let's look at the chapter 4. It's the best practices for stored procedure development. And before we start, let's see what is stored procedure and why are we using that. A stored procedure is a set of SQL statements and control statements. A stored procedure is compiled when it is created rather than when it is executed. It supports transaction management, allowing you to start, commit, and roll back a transaction inside a stored procedure. By using stored procedures, there are a lot of advantages. The first one is SQL requests are compiled before execution when we are using stored procedure. So the execution efficiency of stored procedure is higher than that of separate SQL statements because the stored procedure is a single batch of compiled code. And secondly, multiple SQL statements can be encapsulated within a single stored procedure, reducing network traffic and improving the execution efficiency. And thirdly, stored procedures enable unauthorized users to indirectly access the database under control, ensuring data security. And now let's see the create statement of a stored procedure. We specify create procedure with its name, and below are some specific parameters that can be used to set the characteristics of the stored procedure. And finally, connect is or as to our main SQL statements. Here we introduce several commonly used parameters. First of all is the package. Package indicates whether the stored procedure can be overloaded. And auth definer parameter specifies that the stored procedure will be executed with the permissions of the user who created it. And thirdly, shippable or not shippable parameter indicates whether the stored procedure can be pushed down to DNs for execution. For the management of stored procedures, we can use the alter procedure to modify parameters of it, and use drop procedure to delete a stored procedure. And now, after the brief introduction of the concept, let's see another database object, which is function. Function is in some way quite similar to stored procedure. A function is a subprogram defined within the database and can be called by SQL statements. Functions and stored procedures have some similarities. For example, both functions and stored procedures are a set of SQL statements that can be executed repeatedly. They are both designed to simplify the tasks of application developers, reduce network traffic between database and the application server, and improve the efficiency of data processing. But of course, function and stored procedure have some differences. First of all, stored procedures are only compiled once, whereas functions are compiled every time they are called. And secondly, functions are usually used in SQL expressions, but stored procedures can only be called explicitly. Thirdly, functions are used to perform some simple calculations and queries, but stored procedures are used to complete some complex database operations and database management tasks. For example, data import, data backup, and restoration. The syntax for creating function currently supports two compatibility modes, which is Postgres style and the Oracle style. And now we simply introduce the Postgres style here because the Oracle style is very similar to that. So when creating a function, we specify create function with its name. And after that, we can define its argument name, argument mode, and argument types. And after the definition of the function name and its arguments, we also can specify a lot of parameters here. And these are very similar to the parameters of the stored procedures. For example, the package here, it also means that if we specify that, it means the function supports overloading. And we can create functions with the same function name, but different parameter lists. And also, we have a parameter of fenced or not fenced. It specifies whether the function executed will be in protected or unprotected mode. So if we specify it as the fence mode, the function is executed in the new fork process, so that any exception to the function will not affect the DN or CN processes. But when we specify the not fence mode, it means the function will be executed right in the CN or DN process. So if there are some exceptions of the function, it may affect the CN or DN process itself. And for more parameter introductions, please refer to the Huawei Cloud official website documents. And also, due to differences in syntax between Postgres and Oracle functions, so although they are quite similar, but they still have some details that are different. So you are advised to use a uniform style when creating functions. And after we see the definition of a function, we also can use the alter function statement to manage a function. We can actually change its arguments, for example, change the argument modes, change the argument name, and change the argument type. And also we can change its parameters. And these are some examples of the alter function statements, and also some example of the drop function statements to delete a function. And next, we're introducing how to actually execute functions and procedures. We can simply use the call statement and specify a particular function name or procedure name and with its parameters to execute a function or execute a procedure. So here we just create a simple function to add up two integer numbers. And after the creation, we can just use call or the select statement to execute that. And that is the same for the store procedure execution. And now, after the introduction of functions and store procedures, we now introduce the concept of PLC code. We use PLC code to write the inner logics of store procedures and functions. And first of all, we introduce the basic PLC code statements. There are some variable definition statements, value assignment statements, and call statements. So here, for the variable definition, we use the declare statement here. Here is an example of the declare statement, and we simply declare the variable name, variable type, and its initial value. The scope of a variable indicates the accessibility and availability of the variable in code blocks. A variable only take effect within its scope. So as we can see from the example here, we declare the employee ID variable in the outer block and specify its initial number as this. And also we declare it again in the inner block and specify another initial value. So when we are trying to print the value of employee ID in the inner block, we display the value that is assigned in the inner block. But when we are trying to print that in the outer block, we just print out its value that is assigned in the outer block. And after the introduction of the basic statements, in PLC code, we can also write some dynamic statements. And for a store procedure, they can execute the dynamic statements. So actually, they can execute dynamic query statements, execute dynamic non-query statements, dynamically call store procedures. This means that a store procedure can dynamically call another store procedure, and it can also dynamically call an anonymous block. So now let's first take a look at executing dynamic query statements. So there are basically two methods to execute dynamic query statements. The first method is using the execute immediate statement. We specify execute immediate with a dynamic select string and specify the into statement to actually store the result of the dynamic string to a defined variable. And the using clause is to specify the variable to use when there are placeholders in the string. So here is an example here. We specify execute immediate with a string, SQL string, and there's a placeholder here. We put that the result of that SQL statement into the staff count variable and using staff ID as a placeholder. So actually, 200 here is specified as the placeholder. And another way for executing dynamic statements is the open for statements. In this case, we open a cursor name for a dynamic string and using a specific value as the placeholder. And on the right side is an example for that. We open my cursor for a specific SQL string using 30 as the placeholder. So after the execution of that, the result set of the SQL statements is stored in my cursor. And then we can just write a while loop to go through my cursor and print out each line of the result set. And finally, for PLC code, there are also control statements. For control statements, it's quite straightforward. It's very similar to the control statements when we are using in the programming languages. They are return statements, conditional statements, loop statements, branch statements, and goto statements. First of all, the return statement is used to return control from a stored procedure or function to the caller. There are two ways to specify the return statements: the return next syntax and the return query syntax. So for return next, we simply return each row of the result sets. But for return query statement, we can return the whole result set at one execution. After that is the conditional statements. This is quite simple. So for conditional statements, we support a set of if-else statements, and here are some examples of that. And also there are loop statements. So for loop statements, GaussDB have 5 forms of loop statements: simple loop statements, while loop statements, for loop statements, and the for all batch query statements. So the example here on the left side is a while loop statement example, and on the right side is a for loop statement example. And also we support the branch statements, and this is quite similar to the case 1 statements in our programming languages. We can specify a specific variable as the case, and we can specify different logics in the then after the then keywords. And finally, it's the goto statement. A goto statement unconditionally transfers the control from the current statement to a label statement and changes the execution logic. So we need to notice that we should better only use this statement when necessary, and the label statements must be unique. So here is an example. If we specify go to position 1 in the if clause, we can just jump to position 1 here and execute the code blocks after that. For goto statements, there are some notes to be noticed. The first one is a goto statement does not allow multiple label statements, even if the statements are in different blocks. Secondly, a goto statement cannot transfer control to the if case or loop statements. Thirdly, a goto statement cannot transfer control from one if clause to another, or from one when clause in the case statements to another. And also, a goto statement cannot transfer control from an outer block to an inner begin-end block. And finally, a goto statement cannot transfer control from an exception handler to the current begin-end block, but it can transfer control to the upper layer begin-end block. And so that's all about the chapter 4. And here we would also like to take a small quiz. There are 3 questions here. The first one is, can a goto statement transfer control to an if case or loop statement? And as we mentioned before, the answer is no. We cannot transfer control to the other control statements in the goto statements. The second question is, which of the following column is better as a distribution column for hash distribution? And the answer is A here, user ID. Because in maybe, for example, in the user table or in some other business tables, the user ID is usually unique. And so when we are choosing user ID as the distribution key, we are highly probable to get a distributed table that is evenly distributed on different DNs. And the third question is, what are the consequences of numeric calculation or comparison performed on data stored in columns of the character type? And this is a multiple answer question, and the answer is the 3 of them. First of all, there will be overhead for unnecessary data type conversion, and also the index on this column will become invalid, and also the query performance will be affected. And that's all for the course of database specifications development. This course provided some suggestions on the naming and design of database objects, and also we presented some best practices for the table design, which includes distributed table and regular tables. And we also provide some best practices for writing SQL and the practices for us to write the store procedure and functions. We also provided some precautions for using the database. And that's all for this course. Thank you very much for watching and listening.